welcome back. So in this video we are going to understand the problem number 2906, construct product matrix. So what if I told you that the problem asking you to multiply every element in a 2D grid except itself? So can be solved in just two simple passes, no division, no extra complexity, just a clean code of O of n times, right, into m, we can say. So that's give you the most people where they miss in the first attempt, right? So let's try to understand. This is Leetcode 2906. We have to construct the matrix, right? We have to construct the product matrix, and by the end of this video you will not only solve it, but you will understand exactly why the solution works, whether you are a beginner who just started DSA or someone preparing for the FANG interviews, and this one is worth your time. So let's try to understand. The very first what we have given is, so let's go through this problem, right? So let's try to understand first. Okay, what the question is saying, that question saying that we have given a grid, right, that is n cross m, right? We define a zero index to the matrix P of size n cross m as the product of matrix grid. So if the following condition is met, right, each element of the product matrix Pij is calculated as the product of all the elements in the grid except the element at grid ij, right? So this product is then taken modulo of 1 2 3 4 5, and then we will return the product of matrix, right, as of the grid. So let's suppose this is what we have given in the example. You can go through and you can understand. Okay, so let me tell you how the question is asking you, right? The problem we will going to understand. Okay, so think of it like, let's suppose we have a grid, right, and this is our input grid, we can say. So input grid, if we'll talk about, is, let's suppose we have something like this. Okay, where we have 3 cross 2 elements. We will take 1 2 3 4 5 and 6, right? So we have given this n cross m matrix. For we have to fill each cell with their product of all other cells, and then we will take the modulo, right? This is what the question is saying. When we construct from this input array, is what we have to construct. We have to construct, we can say, the product matrix, right? Product matrix. It means when we create a cell, right, of this product matrix like this, right, we have to fill these cells, right, and from these cells, right? But we have to also take, when we are going to fill these values, give me a second. When we are going to fill this, right, so when we are going to fill these cells I'm talking about, right, it means when we fill each cell of this, right, we have to take the product of all other cells, right, and then you will take the modulo of 1 2 3 4 5. We have to take the modulo and then we will fill, right? Let's suppose how. So think of like the very first row, right? Means if I want to fill this field, right, means we have to take the product of all the other cells, right? So let's say if I want to take, means we have to take 2 into 3 into 4 into 5 into 6, and this will come approximately 720, right? So let's say 720 will come here. Okay, then when we are going to fill this, means we will not take this one, but we have to take the product of all of these, right? So let's suppose that when we will create this, let me clean this. Okay, so when we take the product of this, right, so it will come, let's suppose 1 into 3 into 4 into 5, right, like that. So 2 is missing, so this will give you result 360. So we'll say 360. Okay, similarly when we'll create, when we'll fill for this one. So let's suppose I have already calculated. So we'll say 240, 180, then 144 and 120 will come. Like this it will come. You can see in the example also, right? If you go little bit here, okay, it was not given. This is different example. Okay, so if you'll fill this, you will get the value like this, right? So what does it mean? Can we say that, guys, we have understood very simple thing is each cell is nothing but what? Each cell is a product of all other cells, right? In the entire matrix, right? And then we'll take the modulo 1, 2, 3, 4, 5, right? This is what the logic we have given, correct? If this logic will work, means we can fill this cell value. So all this cell value we will fill like this, correct? Means we have given this 3 cross 2 matrix, we can say. This is our 3 cross 2 matrix where we have 1, 2, 3, 4, 5 as a input values we have given this grid, and we have to construct the product matrix. So if you read the problem, right, we have read, so you have given this grid of integers and your task is to build a new grid, right, with the exact same size. Means, and if this is n cross m, so this will also n cross m, okay, where each cell contains the product of every cells that we have seen already, right? It will work like this, right? So we have to take the product of entire cells value except the current value, right? And then you will take the modulo, right? And once you take the modulo, you will set the value, right? So we can say the cell value, each cell contains is equal to the product of all the other cells in the entire matrix and then the modulo that we are taking, right? So for each cell at row 0, right, and row column, let's suppose we are talking about, means when row is 0 and when row is column is 0, right, which holds the value 1, right? We are talking about this one. The output should be 2 times, 3 times, 4 times, 5 times, 6 times, right? And then we will set the value and so on. We will do that, right? And we have understood these things. Now think about the approach. Okay, guys, let's think about the approach. We have a naive approach. So as a naive approach, what you will do? Think. Naive approach is too slow. Why? Because if I'll talk about that, for each cell that we are seeing, that we have n cross m as a cells, right? So when we will multiply all others, right, means let's say this is our approach we have, and in this case we have to multiply all other, right, n cross m minus 1 values, we can say that, right, means except the one, the current one. And if we will do this, it means this approach that we are talking about, it will give you the time complexity as Tc is equal to O of n square into m square, we can say that, right? So if we will get this time complexity, right, guys, then it means that it is very slow, way too slow, we can say, for large grid, right? So now we should think about what we need to do. So let's understand the efficient approach and in which we will use the prefix and suffix pointers in the given array. The very first step is to flatten the 2D grid to a 1D sequence, right? So let's suppose that we had a given this cell, right? So we will convert this 2D grid into 1D. Okay, so once you will convert into this, it will look like this array. So one, the value is 1 2 3 4 5 6 as an element in the 2D grid. So we have to convert it into 2D grid to 1D. So it will look like this, and these are the coordinates where the value was there, right? So if we'll convert this in the very first step, what we need to do, we will convert this into 2D grid to 1D grid, right? And we'll take 2 pointers here, right? Very first thing, that if we will convert this, how we'll convert? So we treat the grid row by row as a single array, and index 0 is the top left, right, and index 5 is the bottom right. So if you see from here to here, we will keep moving like this, and this lets us use a simple pointer in the left pointer and right pointer, we can say, for the swap. So next step is to do the swapping. So pass one we will do for the prefix swap, right, where we'll use the pointer to left to right. So for each position, we store the product of all elements before I. So before I, these are the elements that we will use, like prefix at I, prefix will calculate the, let's suppose is 0, and then we'll go like this 1 2 and so on, right? We will keep finding the value. If nothing is there, so we'll treat it as a 1, otherwise we'll keep multiplying the previous values also. Okay, similarly we'll do for the pass 2, right, where we'll do the suffix prefix swap, where we'll use the pointer from right to left, right? Means we have took the 2 pointers, one to left to right and another is right to left, for these 2 steps, where for each position we will accumulate the product of all the elements after I. So let's suppose suffix at I we need, right? So suffix at 5 will start from the right and will keep going to the left side, right? So we have calculated 5 4 and a suffix at 3 also, like this. So in general, we can say if this is the converted array, means from the 2D array we have converted into the 1D array, and then we have calculated the prefix. So let's suppose the prefix we calculated like this and suffix will calculate like this, right? Once we'll do the combined, right? Once we'll combine this result, let's suppose the result at I is nothing but prefix at I into suffix at I. So the combined result is called resultant result, where we have this value will store after the multiplying these two. Let's suppose this one will multiply with 720, so it will become 720. This one with 360, it become 360. For these two, we'll multiply by 120, so it will become 240, and so on. Will find all the result. So for each index I here, right, we'll calculate the prefix at I, what is suffix at I, and then we'll take the mode, right? So this is what we have to calculate, guys, right? This is the what you call the result at I we have to find, right? So what this prefix do, prefix gives you the everything before I, and suffix gives you everything after I, right? And if you will multiply them, right, it gives you the product of all other elements. So make sure that you understand the idea why we are going to use this efficient approach. So if we convert these stages of algorithm, right, 4 stages of algorithm is, the very first step is to, you have to convert the, you have to flatten the grid into 1D, means total element of the grid will be nothing but is n cross n element, right? Means we will treat the 2D grid as 1D array row by row, and we will find the index how, row into m plus column, right? So this is to find the index. So to find the index, you have to use row into m plus column. I'll show you in the code also. Okay, then in the step 2 we have to use like prefix pass for left to right, and similarly for the suffix pass. Okay, so let's think that if we'll do the prefix, right, so prefix at 0 is nothing but initially it will 1, then we'll go for I equal to 1 to n, and we'll find prefix at I is I minus 1, the previous index, that is obviously you will start from the 0, so you will get 1, and the current value of the grid, so you will multiply that value, you will store at I, means 1 to n we are talking about. Okay, and then you will do the mod. Similarly for the suffix, right, for the pass right to left, you will calculate the suffix, right? And so for we'll start from the index, we'll start from n minus 1 to 0, and we'll calculate the first resultant, right? You will multiply the suffix, and suffix is nothing but suffix. You will take, you will multiply the grid, and you will get the mod. In finally, right, in the final step, what you need to do is reshape the grid, right? So you have to reshape the grid, and give me a second. Yeah, so the grid, 1D grid will get converted into 2D, because this is the final thing we have to do, because from 2D we have converted into 1D, right? And then we have applied those steps, so we have to back to do into the 2D array, right? So this is the steps where you will do the result at row and column is nothing but you have to use the flat and array. You will do row into m plus 1, you will get this value, and then the mod, right? You will get result value. So this is what we will do. So let's go to the code and we'll try to use these 4 steps, right? So keep in mind that these 4 steps is very important before developing this approach, right? The very first step is to convert into 1D array, then prefix pass, then suffix pass, and then convert into back to the 2D array. Okay, so let's go to the code. Okay, so the very first thing that we have given is grid we have given. So let's suppose we'll create n, and n will start from the grid dot length. We will find calculate, will calculate the grid n. So we have given grid, so from the grid we will calculate the n, and similarly we will calculate the m. So we know that m cross m is the number of element we have in the grid, so we'll say grid at the 0 and we'll get one cell. And if we'll do dot length, so from the single array you can calculate the length. So m and n we have calculated. Now let's suppose that I want to know the total number of element, right? So let's say that number of element is let's take n, capital N we will take as a variable, and it is nothing but n into m, we can say that, right? So you will get the total number of element here. Now let's suppose we have to take the final also of sorry, mod also. So we'll take final int, and this is nothing but the mod, and the mod value should be 1 2 3 4 5, right? This is the mod value. So once these are done, right, we need a resultant where we will store the element and we'll return, right? So we know that we have to create the result array. So we'll say this is our result, and it will start from the new. We'll call int, and two things we will use for n and m, right? Because n cross m we have, right? So we'll calculate n cross n element we have crossed, so we'll need the resultant also n cross m. The same length we have to use, right? The very first you will use the pass one for the prefix swap, right? To do the prefix swap, right? Not swap, it's called sweep, right? Prefix sweep, where we will use from the left to right, we can say, correct? So we have to store, how we will store the element, right? So let's suppose in this case is we have to store the result. Let's suppose called, if we have I by m, we can say that, and similarly we'll take the value where we'll take the mod, we can say that, as a m. So it will stores the product of, we can say, product of all the elements, not all the elements, we can say, right? V for index I, correct? So let's suppose we'll create a long prefix, right? And we'll start from 1. Prefix value will start from 1. So what we need to do, we'll say, okay, start with the I equal to 0 and go for all the elements of the given, because we have given the 2D, right? From we will treat as a very first top left corner 0 0 to the last m minus 1 n minus 1, right? Will go, right? And that is nothing but we have calculated total number of element is n, because we are treating in one pass as a single array, right? A single 1D array, we can say, right? Like that. So we'll use this for loop like this. Okay. Now think that we will use the result where we will store, as we have understood that we'll use I uh, slash m, we can say that, right? And similarly we'll use I mod m, right? So we'll get the index, correct? So correct, at correct index we have to store. So very first convert into the typecast into the integer, and we'll get the prefix. We'll set the prefix value here as a result. Then we'll calculate the prefix at, we will calculate the prefix again, right? So what we have the prefix currently, and then we'll multiply by the grid at I by m, we can say, and similarly we'll calculate I mod n. So you will get some value here. Once you will get the value, you will take the mod like this. So like this, you will calculate the prefix. Okay. Then in pass to, similarly we'll use, that is called pass to, and this is for the suffix, right? Suffix. And suffix will do suffix sweep, we can say, from right to left, correct? Means we have to multiply in place here, right? So we have to also think about like that. Okay, it means I'm talking about that in these steps we have to multiply in place, that we should also take care. And what are the other things we will do? Like, let's suppose what the suffix will do. So suffix will holds the product of all the elements after index I. So if I'll take a long, right, and we'll say this is my suffix. So from where the suffix will start? From 1 itself, right? Then we'll create the loop. That loop start from n minus I, let's suppose I, which is going to start from n minus 1, right? And this I should be greater than equal to the first element and I minus minus. If you know the reverse of the for loop, right, in a given array, right? So similarly we'll do here. Okay, so now think that once you will, okay, so once you will do this approach, right, what you need to do is, once you will make this loop, like what you need to do is we'll calculate the result similarly that we have done previously. I divided by m, we can say, and we'll use the I mod m, we can say. There we have used I mod m, similarly we'll use here also. Okay, so let's suppose that we will use here as a, whatever the result will come, so we have to convert into the integer because we are taking the long, right? Because we have to take the mod, right? So we will not lose the data. So let's suppose the result at I by m, and similarly I mod m, and some value will be there, right? We'll get some value here from the suffix. So suffix will already contain some value, and there we will take the mod here. Okay, so like this we'll calculate the result. Once you will calculate the result, we know that you calculate the suffix. Suffix is nothing but the suffix, and then we'll multiply by the current value of the grid, where this is the cell value we'll use, right? And we'll take the mod in the last. Okay, once this is done, so you have already updated the result, so return the result. So all these steps is get converted into there. So let me show you. Okay, so after this formatting looks good to me, let's me submit. Okay, so here we are getting, okay, let me check what I have did the mistakes. So result I by m, right? Entered good. So let me check. Then what we have got the error? We check out the error first. So it is saying suffix. Okay, the spelling mistake is there, not a big issue. So here suffix should be suffix. Let me check again. Submit. Okay, so working fine for me, right? So what we have done, that we know all those 4 steps we have converted, right? So we need at least 2 pass 1, pass 2, and we have to merge into, combined into the result. And once it converted into the result, we have to convert it back into the 1D array. So you have to do that, and all those 4 steps we have symbolized in this code. If you have any doubt, you can ask me in the comment box, or If you want to learn DSA in depth, structured way, you can join my online classes. And that's all I have in this video. In case you are struggling with anything, please let me know in the comment section and we'll go from there. Thank you so much, and please like and subscribe this video. Also share with your friends and support Expert Funda for better content and better learning. Thank you guys. Thank you for watching this video. I'll see you in the next one. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.